And begin. Okay, Colossians 1, 16 through 17. For by him were all things created, that are in heaven and that are in earth, visible and invisible, whether they be thrones or dominions or principalities or powers. All things are created by him and for him, and he is before all things, and by him all things consist. Okay, today we're looking at lesson 79, which is de Moivre's theorem, okay? And we're talking about roots of complex numbers, which is all tied together. Now, this is de Moivre's, okay? When we were talking about before, we realized that when we were multiplying two polar forms, we multiplied the absolute value or the number in front, okay? This was the hypotenuse or the radius right there. And then we added the angles. Okay, remember doing this? Now, this is stretching it further and saying, okay, we do this with complex polar form also. When we have a complex polar form, we're going to multiply the two numbers in front. Those magnitudes or absolute values are going to get multiplied. The thetas are going to get added, and that will give us the polar form of this product. Okay, so now they're taking this a little bit further. They're saying, okay, well, let's let z equal the polar form, okay, r cis theta. What's going to happen when we raise that whole thing to a certain power? If when we multiply it, we multiply the two absolute values and then add these, then when we are raising this whole thing to a power, doesn't it make sense that this r in front will be raised to the n power? And this theta, each one of it will be added. In other words, they're going to be added together, so it's going to be n times theta, because you're going to have theta in there added to itself n times. Okay? So this is our formula for raising, this z is the polar form to a power, okay? And then we get this, all right? So that's de Moivre's. So now, when I look at this and I'm saying, okay, if I'm going to take this one right here, 2 cis 30, this is, and we're going to raise this to the 5th power. And this is the first example in the book. So this is not hard, right? All I got to do is take the 2 and raise it to the 5th power and get 32. And then cis, the 30 is going to be in there 5 times, so it's 5 times 30, or 150. Okay, so 32 cis 150 degrees is the answer. How easy can it get, right? Okay, so now, this one's a little tougher, because what's this? This works in polar form. Now I'm given something in rectangular form. It would be easy to do if I had it in polar form, but what they're asking you to do here is take this polar form, turn it into take this rectangular form, turn it into the polar form, raise it to the 13th power, and turn it back into rectangular form. So it's got a few more steps to it. So let's do this one. When I am doing a 1 plus I, I'm going to be going one step to the right. Remember, this is called the Argand plane, where you have a real axis this way, and you have an imaginary axis this way. Okay? So basically, isn't that at 45 degrees when I'm going 1 over and 1 up? It's a 45-degree angle, isn't it? I don't even have to put that and take an inverse tangent of it, because I know 1, 1 is a 45-degree angle, don't I? So what is this? What is this hypotenuse if I have a 1 and a 1?
Square root of 2.
Square root of 2. I don't even have to do any math there. So square root of 2, cis, because it's imaginary, and then 45 is that polar form. Correct?
Yes.
Okay, so now what am I going to do? I'm going to take this one and raise it to the 13th power. Now that I've got it in polar, I can use my de Moivre's. All right, so it's going to be the square root of 2 to the 13th power. Now, isn't that square root of 2 the same thing as 2 to the 1/2 power to the 13th power? Okay, so what's that going to have? 2 to the 13 halves would be what? How many whole 2's would that be?
6.
2 to the 12th would be, square root of 2 to the 12th would be 2 to the 6th. Okay, 2 to the 6th is? 64. So am I going to have 64 square root of 2? Does that make sense to everybody? And then sis, what's going to happen when I take 13 and multiply it by 45? 45 times 13, if you have a calculator, do it.
585.
585? Okay, so I got a 585. But remember, 585 is over one full trip around the unit circle. So what can I do? Minus the 360, right? Can I minus the 360? And I'm going to get a 522. So sis, 225. All right. Now, that is my answer. But they wanted the answer back in rectangular, right? So what will I do? I'm going to take...
It's a 45.
Okay, that's a 45 in which quadrant?
Third.
Third quadrant. Okay, so basically, I'm looking at this, my 45 down, and I'm looking at this distance here being 64 square root of 2. Okay, right there. And I've got to get the polar of that. So remember what cis means. Makes it very, very easy if you remember what cis means,
Isn't
right?
that polar form?
Cosine plus, yes, but we're to get it back in rectangular. Okay, so cosine plus I sine. So can I take this whole thing and say, oh, well this is 64 square root of 2 times...
Square root of 2 over 2.
Right, it's the cosine. I'm going to write it out first. Cosine 225 plus I sine 225, right? So then, realizing it's a 45 in the third quadrant, what is my cosine?
Square root of 2 over 2.
But it's left, right? It's left, so
Negative
my
square root
cosine will be
2.
negative. Negative square root of 2 over 2 plus I sine is
Square root
down,
of 2.
so it's also going to be
Negative
negative square
square root
root of 2 over 2. And then when I multiply this through there, right, this one goes through there, I'm going to get the 2 square root of 2's are going to make a 2 that's going to cancel with a 2, and I'm going to get 64 negative, right?
What?
And then plus I, then my square root of 2's multiply to give me a 2, and that'll all cancel. So I got a 64, but it's negative I. So I don't have I've got a negative 64 minus 64I, which is correct, okay? And that is...
Good job.
That is how you're going to do those. You're just going to write out what cis means, and then go pick it apart, remembering your signs, and then take your 64 square root of 2 and multiply it through.
I thought your square root of 2 and negative square root of 2 would make a negative 2.
Your square root of 2, and this one multiplied by this one gives you a square root of 2. It divides by the 2. This one makes a 2. It divides by a 2. That's a 1, but it's a negative 1. So when I multiply negative 1 times 64, I get the negative 64. Okay? All right, now let's look at this one. Before we look at this last one here, I want you to look in your book. Yes? Yes. I want you to look in the book, and I want you to read down at the bottom of 481. Okay, who can read that nice bold print for me at the bottom of 481? Okay, go ahead, Mark.
Every duplex number except 0 has 2 square roots, 3 cube roots, 4 fourth roots, 5 fifth roots, and in general nth roots.
Okay, stop right there. So, what is he saying? That if I'm looking for a cubic root, how many will I have? 3. I'm going to have 3 cubic roots. Okay, I'm